Hi, I'm Lars from dSPACE. Today I will show you how we support OEMs with ready-to-use NCAP scenarios. Especially relevant this year, because the Euro NCAP regulation has undergone a huge revision. NCAP, the new car assessment program, allows OEMs to use virtual testing to validate their safety functions. And many of them already do. However, NCAP scenario creation is time-consuming and go beyond normal scenario creation. NCAP scenarios go with several challenges. More than 60 scenario types, over 1,000 parameter variations, complex trajectories, impact points, and 3D assets. OEMs prefer to focus on their functions, rather than spending resources building and maintaining NCAP scenarios. This is where dSPACE steps in. Our solution is to provide complete, ready-to-use NCAP scenario database for direct execution in our product ASM Traffic. To make this manageable, we deliver importable artifacts for model desk containing logical scenarios, raw definitions, 3D objects with defined impact points. Using our Python scripts, you can automatically generate concrete scenarios that comply with NCAP regulations. Let's look at an example. I'm going to import scenarios from the crash avoidance protocol. For our demonstration, I will use CBNA scenario. In this scenario, the ego vehicle and the bicyclist cross their paths. The cyclist approaches from the near side, from the right. In the safety function doesn't brake in time, the ego vehicle's front will hit the cyclist on the left side of the crankshaft. Now, let's do a little math. Let's drive the ego vehicle at constant speed. To hit the target at a certain point, we need to determine where the bicycle starts moving. Here's the idea. The target follows a trajectory that includes acceleration phase and a steady state phase. We calculate the target's travel time to the collision point. Knowing the travel time of the target at constant ego speed, we calculate the trigger distance, the point at which the ego vehicle must pass so the target begins moving. We also consider the shape of the vehicle's front, which is often curved and influences the exact collision point.
Hello, you might have seen all of this and wondered, how complex would this be to automate? I can show you it's not that complex at all. If you use the Test Automation SDK, you only need to use easy and simple interface to start up and get your environment ready. By the Test Automation SDK, you'll be able to parameterize the scenario, and even in this case, for this demo, start up Aurelion to visualize the current scenario. This will run on both simulation environments, whether it's a HIL or a SIL. And now we're in Visual Studio Code. I chose the scenario that Lars just explained in the presentation, a CBNA scenario. At the beginning, we do the mathematical calculations needed to synchronize the path of the ego and the target. After we do these calculations, we initially load the scenario to model disk, and then with a simple interface, we're able to take these calculations and parameterize the scenario with it. Then we initialize and download the scenario. We start the test case, we start the capturing of the relevant variables, and then at the end of the test run, we evaluate the results. And now, I will start with running one scenario. So right now, the car starts driving towards its target. Let's see if it's going to brake. Ouch, that looked painful. I think I forgot something. I forgot to activate my AAV function. Let me just reactivate this and rerun the test case one more time. As you can see, of course, the test case has failed. Now let's run it again and see what will happen. And now we do this one more time. Hopefully, the cyclist survives this time. As you can see, the car was able to recognize the cyclist and brake in time. Now let's take a look at the report. As you can see, the latest execution was a pass. But I would like to also see one of the retries, which was a former execution without the AAB activated. It was a failed. Let's take a look at the report. As you can see, the report logs all of the steps that we have done to parameterize the scenario, and then we can take a look at the capture. So here we can see that there is a collision that has occurred, and we're able to see exactly where this collision happened on the X and Y axis relative to the car's control line. At the bottom side, we also saw that the AAB braking was not activated. When we go back to the past test case, we see, however, that in the capture, it was the same. The maneuver was started, but there was no collision. The car was able to brake in time, and there was no collision. The AAB was activated at the correct time.
Thanks, Yusuf, for this nice demo. If you would like to test NCAP scenarios, please contact us at dspace.com.
dSPACE, your partner in simulation and validation.